Let's investigate this two-way table probability question or contingency table question. This data table describes recent ice cream purchases at a certain diner, whether they were vanilla, chocolate, or strawberry, and in a cup, cone, or a shake. We have several questions to think about here. First, for the probability of purchasing a cup, remember using this recent data, we would find the total number of cup purchases, which is 30, and we would divide that by the total number of purchases altogether. The grand total is 145. So the probability as a fraction would be 30 out of 145. Here, that's about 0.2069. For the next one, the probability that the purchase was a strawberry and a shake, or in other words, a strawberry shake, there is a way to do that using a mathematical formula. But with the two-way table, actually these and type problems are pretty quick to do if you look for the intersection there, right? So if we look for that intersection of strawberry and shake, it looks like there were 17 that fit both criteria. All you need to do is divide that by the total of 145, and that'll give you the probability that a purchase was a strawberry shake. Notice I didn't actually format this cell yet, so we're getting a lot more decimal places than those 4. I'm going to do that now, and I'm going to try to see if it'll format the rest too. Let's change, you can use those buttons to increase or decrease decimal places there. Yeah, it's not letting me do that for multiple. So we'll decrease that down to 4 decimal places, and we can see that that's about 0.1172. For the probability that we get a purchase that was either a vanilla or a cone, that is the case where we're going to have to actually do some addition and subtraction. First, we'll find the probability that we get a vanilla purchase, and that would be 65 out of 145. Then we'll add the probability that we have a cone purchase, which would be 55 out of 145. But notice if we intersect the column of cones and the row of vanillas, there's a number that's in the intersection there of 35. It means that those 35 purchases we've counted twice. We included that 35 in the 55, but also in the 65. So what that means is, since we've double counted those 35, we need to go in and subtract that probability of getting both. Right? So we're going to subtract the probability of getting both, which is 35 out of 145. That's going to result in a probability to 4 places of about 0.5862. Notice you could have actually found the numerator first and then divided it at the end. Right? So we could say there were 65 purchases plus 55 cone purchases minus that overlapping 35. We can add and subtract those in parentheses, then divide by the grand total of 145, and we'll see the same probability there. So for part 4, we want the probability that the purchase was chocolate given that it was a shake. So this is what we call a conditional probability. So in this case, we're not looking at the entire set of 145 recent purchases. We're only interested in the ones that were shakes. So we're saying, given that it was a shake, or assuming that the purchase was in shake form, what is the probability that it was a chocolate shake? And so that's going to look like, we would not use the grand total of 145, but instead we'll use that subtotal of 60. Out of all the shakes that were purchased, what is the probability, or what percent of them were chocolate? It would be the 30 over 60. So we would divide 30 by 60. We know that's going to come out to be 1/2 or 0.5. Question 5 is asking, are the purchased vanilla and purchased a cone events disjoint, or in other words, mutually exclusive? Remember, that just means, can they happen at the same time? If it's possible that a purchase can be considered both, then we would say that they are not disjoint because they could occur simultaneously. So that is the case here, right? All we need to do is look and see, are there any purchases that were vanilla and cone? And it looks like there were, those 35 that we talked about earlier. And so we would say no, since those events could occur at the same time. Or you could even provide the number. You could say, no, there were 35 purchases that were both vanilla and cone. Right? Something like that would work. For number 6, they're asking, are the events purchased a shake and purchased chocolate independent? Why or why not? Take a second to think about these two. I listed, and this is one way to think about this, I listed the probability of purchasing a shake and the probability of purchasing a shake given that it was chocolate. There are many ways you can approach independence, but this is one of them, right? Choose one of the events and find the probability of that event happening regardless of the other event. Then double check that same probability, adding on that new information, assuming that the other event did happen. And if we compare those two probabilities, if they're significantly close together, we'd say that they're independent because it looks like there was no difference. But if the probabilities are significantly far apart, we would say that there is a difference in those probabilities, so that they would actually be considered dependent, right? Knowing whether one event happened would actually affect the probability of the other. So let's see what happens here. If we want the probability of choosing a shake, that would just be the 60 out of 145. If we want the probability of choosing a shake given that it's chocolate, we're going to be looking inside just that chocolate row there. Right, so we're going to say out of the 45 ice creams that were chocolate, 30 of them were shakes. And so this would actually be 30 out of 45. Notice earlier we did the probability of chocolate given that it was a shake, and those are not the same thing. Right? That's usually the case. It would be a coincidence if they were. So I'm rounding those to 4 places. It looks like those two probabilities are very different. So it looks like the probability of a purchase being a shake increases by a lot if we know that it's considered to be chocolate. And so that means that we would say that no, these are in fact dependent events. Right? Knowing information about one would seemingly impact the probability of the other.